Bobby Watkins he currently serves as director of the NASA Marshall Space Flight Center Human Exploration Development and Operations Office, or HEDO, H-E-D-O. He manages all human exploration and operations program work except for the Space Launch System. His responsibilities include overseeing Marshall's role in the development of the Habitation Element for the U.S. Habitat Module for NASA's Lunar Outpost, the Gateway project. He oversees the International Space Station performance of round-the-clock station payload operations, the development and sustainment of the station's environmental control and life support system, the Marshall Flight Center's support activities for NASA's Commercial Crew Program, and the Orion Launch Abort System, and also the development and operation of ground support systems for programs and missions. There's a pretty impressive stuff, and it goes back further than that. Bobby Watkins began his NASA career at Johnson's Mission Operations Directorate in 1986, and as he moved through the ranks and gained more experience, he has played many significant roles in the space program. And I just like to read you a few of those because it's really impressive, including leadership roles in the Space Shuttle program at Johnson, manager of the Space Shuttle Planning and Evaluation Office, and the Space Shuttle Orbiter Element Technical Liaison at NASA headquarters. He was Johnson's chief engineer and then chief of staff at the Johnson Space Center, director of the Office of Strategic Analysis and Communications at the Marshall Space Flight Center, director of the Legislative Liaison Division at NASA headquarters in Washington, D.C., director of the NASA Michoud Assembly Facility in New Orleans, and this multi-tenant manufacturing facility is also where the SLS, the most powerful rocket in history, and the Orion spacecraft are being developed for space exploration. Bobby Watkins was also a member of NASA's Astronaut Selection Board in 2009, 2013, and 2017. He has received numerous awards and medals from NASA for his outstanding service and leadership. Bobby earned a bachelor's degree in mathematics in 1986 from Albany State University in Albany, Georgia, and Albany, Georgia happens to be his hometown as well. It is a great honor and pleasure to welcome Bobby Watkins.
Pierre. I want to thank Pierre for those wonderful words, but then again, I also want to thank Fred as well for giving us an opportunity to reach out to NASA so we could have this discussion tonight. So it's my pleasure to be here from a little small town, as Pierre was saying, Albany, Georgia. I was the youngest of 5, so my siblings would probably say I'm spoiled rotten because I want everything my particular way, which is not the case at all. The youngest is just the most special kid of the family. He's the last one. All right. So, but it's been a phenomenal career, and I'll tell you what, I think about my parents. My father has passed on now, but I think about my mom and all the work they did. We owned a small business growing up, and started out with a little gas station that my dad basically trained himself how to be a mechanic. Just a phenomenal guy, you know. Thinking about my dad, he had a 6th grade education. My mother had a 10th grade education, and they had 5 kids they all put through college. And had us working at the family business, learning how to solve problems, learning how to work with people, learning how to work on teams. Those are things that I use each and every day throughout my career. So I'm very blessed, very fortunate to serve, and it's a privilege to work at NASA. I came in '86. My goal was to stay for 2 years. I failed. All right, I failed. And but it was one of those things where I just really liked the mission. I liked the overall concept of what we were doing and the special work we were doing for humankind. So I thought it was just a unique place to work, and I just really enjoy that kind of work. When I first came to NASA, I'll tell you guys a quick story, then I'll get to these charts here for discussion. So when I first came to NASA, I worked in Building 30, the Mission Control Center. And this is a historic control center where we had Apollo and all the Saturn launches, and you know, we were watching all the things that were going on with the crew and also with the vehicle. And there was a guy who used to wear the little vest and had the little crew cut. And I didn't know the historical value of this particular gentleman. When I came into the organization, he was actually he was my big boss. He was my director. And this guy, name was Gene Kranz. So if you guys ever heard of Gene Kranz, that's where I started my NASA career. Coming in as a young engineer in the organization, you know, you're kind of on probation for your first, actually 18 months. But I had to go in for the first 6 months and do what they call like a technical intern presentation, where you talk about all the things you were learning in the organization. And back in those days, I was doing a lot of work with communications, how to data, came into the control center from other parts of NASA, and then how it get distributed to all those consoles that you see on TV. So each console gets different data, have access to different data. And I was part of the team was looking at how that data would come into the control center and get distributed out to the rest of the team. So I had to go in and talk to Mr. Krantz at that time. Been on board for about 6 months. I go in, little kid from Georgia. I'm shaking in my knees. I'm like, what am I doing? Why am I here? And I go in and I have probably about 5 or 6 charts. And I'm talking about all the work I had worked on, the teams I had worked on, everything I had learned in those 6 months. I worked on those charts for probably about a good 6 weeks getting ready for this presentation. This is the big boss, so you couldn't fail. So I go in and I brief them. Have you ever had a conversation with your significant other or with a group or with someone and you don't remember anything you said? Has that ever happened to anybody except for me? Anybody? Has that happened to anybody? It happens to me. I walked in that room and I just started talking. And I talked and I talked and I talked and I talked and I looked up and I was on my last chart. And I said, sir, that's all I have. And I walked out and I felt bad. I said, my gosh, I have let my family down. I have let myself down. I can't believe I did that terrible of a job. Went back to my office. My boss came in. At the time, his name was Gary. Gary came in and he said, Bobby, and I just immediately, I started to apologize. I am so sorry, sir. I let you down. I let the organization down. I let myself down. I feel terrible about this. He said, what are you talking about? And he said, I just feel like I didn't give it my best job. And he said, well, Gene Krantz, that he said, we need to keep our eye on you. So I'm so sorry. I just knew, I knew I can do a better job than that. I know I can do a better job than that. But he really was saying at that time, early on in my career, they saw I had potential. And NASA has really gave me a lot of opportunities to lead organizations. Sometimes things go very, very good. Sometimes things don't. But each one of those opportunities, I have learned different parts about this organization, spent time at NASA headquarters, spent time at the Johnson Space Center, and spent time at the Marshall Space Flight Center. Typically when people work at NASA, they kind of focus in on one or two things, but I had the gift of being able to spread across multiple things. So I did everything from technical work to business systems work to working with legislators and walking on Capitol Hill and telling people why NASA is important. So I don't know how I had a chance to do all that, but I've been very fortunate and very blessed. So I'm very thankful to be here tonight. Do you guys go by MU or Marion? Which one? Marion University or MU? Which one can I use? Marion. All right, we're going to use Marion. Thank you, Marion, for having me tonight. All right, and with that, so let me tell you a little bit of what I'll talk about tonight. I want to talk a little bit about the future of space exploration. But when I talk about the future of exploration and where we're headed, we just had some pretty big announcements that just happened over the last less than a month ago. But I'll talk about the future where we're headed. But I also want to touch on the work we're doing now when it comes to human space flight. And then I'll talk about at the end, my third point will be, I'll talk a little bit about the future, what we're doing now, but how those two work together to allow us to go even further into space. So I'll try to tie all that together, okay? Does that make sense? All right, feel free. I'm okay with questions and things of that nature, so feel free just to jump in. Again, we got a collective body. I may not have all the answers, but collectively we will have all the data we need. So great presentation. So with that, I may ask for a little help. I got it. I think I got it. Okay. All right. All right. Let's see. Apollo 11, 50 years ago. Coming up this summer, July 20th, 1969. I was 5 years old, but I think I vaguely remember my parents talking about a human going to the moon. I'm like, oh, that has never been done before. I'm thinking, okay, where are my little toys? Let me get back to playing with my little toys. But that was very historic. You think about landing a human on the moon. So NASA's in the process now, get ready to celebrate. There'll be celebrations all over this country when it comes to this Apollo 11th anniversary, 50th anniversary. That was a huge achievement for humankind. So the work that we have continued to build on with those particular astronauts, Neil Armstrong and also Buzz Aldrin, that is huge for the kind of work that set the path for NASA to move forward. That was the footprint that allowed us to continue to do the work that we do now for space exploration. We'll continue to do that particular work, and then we continue to actually advance in the field of space exploration. Next chart. About a month ago, March 26th, our Vice President, who is the chair for the National Space Council, was at Huntsville, Alabama, and he made an announcement that NASA will return to the moon in 2024, putting humans back on the surface of the moon, men and women back on the surface of the moon. That was a huge announcement that we had on behalf of NASA. The National Science Council, of course, is sponsored as part of the administration from the White House, from the president. President was all on board with this particular announcement, and to have that kind of support for NASA from our administration, from our White House, is huge for the work we do for NASA. We cannot do these journeys alone. These are huge, very detailed assignments that we have. Now, we got a lot of work that we're going to have to do on behalf of NASA over the next 5 years to hit that 2024 time frame. Before we get to 2024, we're going to try to do what we call a lunar mission around the moon with a couple of crew members or a few crew members, just to test out some of the systems and see how things are working, make sure things are working well. So we do that in 2022 time frame, and then in 2024 land a human on the moon. So again, people ask all the time, so well, Bobby, you guys have been to the moon before, so what's going to be different about this particular mission to the moon? Next chart. When we went to the moon before, believe it or not, scientists are still, some of the samples that were collected back 50 years ago, scientists are still utilizing some of these samples, learning from these particular samples. This particular mission, of course, we want to go to the south, what they call the South Pole of the moon. The South Pole could be a very huge resource when it comes to frozen or ice, frozen water. That ice could be energy that we could use for fuel. At the same time, we want to make sure that we have a sustained presence on the surface of the moon. This is not going for a couple of days and then returning back home. We're talking about platforms that will allow humans to live on the surface of the moon for 30 days, 60 days, all the way up to 90 days, doing robotic missions as well as human missions on board the surface of the moon, taking samples, understanding the makeup, what kind of materials are needed. You know, the further you go out into space, the materials that we have on right now, I couldn't wear this suit out in space. I need what they call a space suit to go out in space. Those are totally different materials than we have. And we got to understand the environment so we can have the right equipment to support our crew members when they go onto the surface of the moon. If they're doing some drilling techniques, the type of materials you need for a drill or a shovel, things of that nature, things are just totally different. And you also have to worry about the dust samples and all other different things, helium-3, all those particular things, and making sure that that crew member is protected in that particular environment. Those are all the kind of things that we have to learn when we're talking about going to the surface of the moon. And if you're talking about having humans live or sustain on the moon for long periods of time, there are even more things we have to do from a material perspective. We can do other experiments and research on the particular surface of the moon. So what's different about this particular mission, this is a long-term sustained presence on the surface of the moon. And how we're going to do that? We're going to do that with Gateway. Next chart. The Gateway, this is a busy chart, so I do apologize for this, but this is a rendition of what the Gateway is going to look like. But when you think about the Gateway, of course, we got to have power, we got to have air, we got to have what we call life support systems for the crew as well. So we're in the process now trying to get the overall architect pulled together for this particular Gateway. The Gateway will be in the lunar orbit of the moon, but it will allow crew members or vehicles to come and actually dock with the actual Gateway. Then they can actually live on that Gateway up to 90 days. When they're in the Gateway, they can be doing research, they can be doing science, but at the same time, they can also have another vehicle, a lander vehicle, that would take them from the Gateway down to the surface of the moon. So those are the things we're in the process of working out now with NASA as part of this president's announcement of going back to the moon and having sustained presence for NASA and the U.S. and our international partners and commercial companies. So that is going to be a huge daunting task that we're going to have to get our arms around. The teams are working very closely together to make sure that we have all of our systems pulled together to support this particular Gateway activity. The actual habitation module resides in my organization there at the Marshall Space Flight Center. So we're responsible for all of the requirements, definitions, the acquisition strategies, pulling all those systems together to decide how we're going to go off and build this particular habitation module. And that habitation module is where the crew can spend most of their time living, but also doing work, research, and science. We will also have the capability where you can have experiments that are attached to the gateway that can be collecting samples from that lunar environment. So we got experiments on the inside, but we can also have experiments on the outside of the actual gateway. So that's how we have that sustained presence. We cannot have humans that live on the surface of the moon, but you can have ways that they can actually go down to the surface of the moon from the gateway. We're also looking at a concept called a surface hab, where we could have the actual habitation module of the gateway actually docked on the surface of the moon. But those are all the pieces that we're working through at this particular point in time. All right, next chart. All right, how do we get to the surface of the moon? Well, we need a spacecraft. That spacecraft is called Orion. This spacecraft can seat 4 crew members on board the Orion space capsule. It has all type of new avionics and software systems. We can also have some payload use in that, operational payload use in that particular facility to do science as well. But it's, if you've ever seen the Soyuz capsule, is very, very tight and it's very, very uncomfortable. But you get a little bit more room, you get a little bit more comfort with the Orion spacecraft. So we're very excited about that particular spacecraft and what they're doing in the Orion program. Of course, that particular capsule will be at the almost at the very, very top of that huge rocket that you see on the other side of the screen. That particular rocket is called the Space Launch System. That rocket is built by the team of engineers at the Marshall Space Flight Center. We're talking about a vehicle that is roughly at 322 feet tall, taller than the Statue of Liberty. You're talking about a system that has weighs about 5.7 million pounds, and it has a thrust capability of 8.7 million pounds of thrust. That is a huge, huge rocket. At the same time, you think about the old Saturn program, the Saturn V Apollo program we had with the Saturn rocket. This particular rocket is 15 times, has 15% stronger thrust than what we had with the old Saturn. If you ever seen one of those launches, the sound of that particular rocket, this one is going to be even larger. So again,
15% more than Saturn.
15% more thrust. 15% more thrust than the Saturn V. Excellent question. Excellent question. So you got to have a huge rocket. You got to have a rocket that can carry and also deliver and get humans to the moon. The moon, you think about the moon, is 250,000 miles away from the Earth. That's a pretty good, significant journey. So we got to make sure we do this correctly. We got to make sure the systems are ready. We got to make sure the rocket is ready. We got to make sure our crew is trained and ready to go. And those are all the things that are taking place now so we can meet the president's and the vice president's initiative to return humans to the surface of the moon for a sustained presence. Okay? Next chart. All right, shifting the gears a little bit. So I talked a little bit about the future, where we're going. We're talking about the systems, the rockets that would get us there. I talked a little bit about the gateway and how we have a sustained presence on the moon. Now let me talk about what's going on today. As we speak, we have 6 astronauts, 6 crew members on board the International Space Station doing research and science. Even when they're asleep, we have a team of folks that can still operate what we call payloads while the crew members are asleep. So we put all those particular systems together. This particular operation, the payload operations, the science, where we're talking about a microgravity type research experiment, where we're talking about an instrument that's collecting samples outside of the actual International Space Station. We're talking about growing food on board the International Space Station, lettuce and things of that nature. We also do a lot of biological science, taking blood samples and things of that nature on board the International Space Station. Those are things that take place each and every day. About 4:30 or so, we had a Cygnus, Northrop Grumman cargo resupply launch that took place. That was a successful launch, and it's on its way to the International Space Station. It carried roughly about 7,500 pounds, 7,500 pounds of cargo and science on board to the International Space Station. With that, this particular week, we should hit roughly about 50 hours of science and research with the crew. And then next week, we're planning on 80 hours of science and research. Now, you may ask why that's important. Just a few years ago, we spent a lot of time building the International Space Station, doing all the systems, getting all the components put together. Also, we got to make sure we take care of the actual crew and make sure they have all the things they need to be successful in space and take care of their care and their needs. Now, we have shift gears a little bit. The third priority is doing more research in science. So my particular team, we went through a huge exercise probably about a year and a half ago to get ready for this increased science. Before, a few years ago, maybe 2 or 3 years ago, we were doing about 20 to about 35 hours of research and science per week. Then we got up to 50 hours of science per week. Then we got up to 80 hours of science a week. Now my particular team right there at the Marshall Space Flight Center, right there in Huntsville, Alabama, now we can actually go above 100 hours of science and research per week. So what we're trying to do is maximize the science and research. We do a lot of medical research, pharmaceutical research on board the International Space Station as well. So this is a national laboratory that has been in space for several years. We have been doing payload operations, doing all the experiments and working with the crew on a day-to-day basis. And once we get this data, this information from the particular experiment, that data comes back down to my facility and then is provided back to the scientist or researcher, which could be anywhere in the world. We have researchers and scientists in over 60 different countries around the world. So we provide that data back to the scientists. We can also work with them real time if there's a problem and do all the diagnosis to understand if there's an issue or problem and then communicate that back to the crew so we can continue that particular science. So we're very proud of this particular national laboratory. That's my heart and dream. When you look at the actual right there, we see the operators sitting there doing their work on a day-to-day basis. And remember, this is an international space station. So we have international partners that we work very closely with too when we do all the science and research on a day-to-day perspective. So a lot of great work that is taking place each and every day. And you think about how long humans have been in space. In some cases, now maybe not this group, I was going to say normally I can pick out 1 or 2 individuals saying we have been in space longer than these particular folks have been around, but I won't say that tonight. So I'll leave that thought to myself. All right. We got a more experienced audience tonight, so I won't say that tonight. But again, we have done some wonderful work with the International Space Station. Next chart. Again, just more science that we do, more experiments that we do. Next chart. All right. So one of the things we've been working on for the last few years is trying to get our commercial partners more involved in the work that we do on behalf of NASA. Just about a month ago, SpaceX did what they call their demonstration mission. This is one of their first missions where they were demonstrating their capabilities to safely carry crew members into space to the International Space Station. I went down for their flight test readiness review. This is where all of the engineers and managers come together and make sure that we got good systems to the best of our ability and making sure those systems are ready to go. So SpaceX, a very successful launch that they had just a few months ago, and now they're getting ready for their crewed mission that's coming up in the summertime, late summertime. At the same time, Boeing is getting ready for their first launch as well. This will be a non-crewed launch to the International Space Station. It would actually go and dock to the International Space Station as well, demonstrating all of its capabilities and systems and ability to navigate and dock with the International Space Station and then safely return back to Earth. So all those systems help NASA with the work that we do on a day-to-day basis. The reason our commercial partners are so valuable to us, again, you think about for years we have been working with our Russian colleagues and flying our astronauts on board the Soyuz rockets. We've been doing that for many, many years now. It's important that we now allow our commercial companies to provide that service on behalf of the U.S. government and fly our U.S. astronauts to our International Space Station. So we're very proud of what those teams have done over the last few years, and we're proud of where they're going to be here later on this year. Yes, sir.
Will NASA use both systems, or will they pick one?
NASA will use both systems. So right now the plan is to use both systems. That way you got backup capability, things of that nature. And not only are these companies flying crew members to the International Space Station. You think about the work that SpaceX and Boeing is doing with ULA, they're actually flying several DoD missions and other cargo experiments and satellites for other countries and things of that nature. So, but we will be trying to sustain or keep both systems flying. So we're very proud of what those commercial companies are doing. And again, that is key to our overall success to get our astronauts to the International Space Station.
Sir?
Yes.
We have to stop any of this during Obama's presidency, or did all this keep going?
All this kept going. All this kept going. So actually, get my dates right here. The commercial resupply effort, I think, started under the Obama administration, if I remember correctly, but don't quote me on that. But they did a lot of work that has been going on during the Obama administration as well as the Trump administration. What happened on the Obama administration was back in 2010, where we had the Constellation program, which was going to build the Ares rocket, and that particular program was canceled in 2010. And then that's when we start working on some of these commercial, and also the SLS, the heavy lift rockets as well. All right, and that program was canceled due to it was running, it was over schedule and over cost. So the skid was behind on schedule and over on cost. All right, good questions, great questions. Keep your questions coming. But again, so we're very proud of our commercial partners and the work that they do. Next chart. So you think about, I talked a little bit about the future. I talked a little bit about what we're doing currently, and you think about how all this work works together. The work that we do to make sure that, you know, the work that we're doing right now for human spaceflight with the International Space Station, we build on that overall success. You heard me talk a lot about the commercials and the importance of those commercial partners when we're talking about getting crew members and research and science and supplies on board the International Space Station. Having that U.S. rocket take off from U.S. soil is one of the things that we are doing from a NASA perspective. We're just around the corner from making those particular things happen. The more that our commercial partners can take over what we call low Earth orbit, the more NASA can focus on going to missions beyond low Earth orbit. You think about it, the International Space Station, you're talking about a vehicle that's about 250 miles in space. That's roughly, I'm in Indiana, so I'm trying to think, it was about 250 miles away. Somebody tell me. Chicago, roughly Chicago. That's like a drive to, a little bit further than Chicago, but a little bit like a drive going to Chicago. So you think about that. Even I pick on my wife now, but she may see this on video, so she's gonna give me a hard time. So with my wife, when we get ready to go, like we went to Jamaica, my wife started packing 2 weeks before that trip came up. And I said, honey, where are you going? She said, well, I don't know what I'm prepared for, so I want to make sure I got everything, and I want to go over my checklist and make sure I got everything squared away. When you think about these complex missions to space, there's a lot of things you have to think about. And then you got to think about, after you pull everything together and you think you got everything solved and figured out, you need to go back and do it again. Because you probably left something you didn't think about. So that's what the teams are doing now. So you think about the work we do on the International Space Station, 250 miles in orbit. We've been working on that for payload operations for over 18 years. But now we're talking about taking another mission to the moon for a sustained presence. That's roughly 250,000 miles from Earth. So that is a daunting task to turn around and do in 5 years. So our teams are working very closely together, trying to figure those particular pieces out. And the ultimate goal is, again, as NASA does more, commercial does more. Once we get to the surface of the moon, we can do sustained presence on the surface of the moon. Our next journey is to figure out what's beyond the surface of the moon. So we need to first figure out what other areas we want to go to, whether that's going to Mars. So that gateway that I talked about, that could be a great, what I call a depot, where if a capsule, space capsule is coming into space, it stops off on the lunar surface, refuel, and then it takes off from there and keeps with its journey out into deep, deep space. So that's what we're working on. That's how those two pieces work together. We learn from what we do today, then we try to apply that for what we want to do tomorrow. Again, you guys have been phenomenal today, and I'll take any questions that you may have. Yes, sir.
Is it more feasible launching from the moon versus from Earth orbit, like in a slingshot sort of way, to Mars. The moon's not that big a deal closer to Mars. I don't know how long the trip is to Mars. Is it 6 months or?
Oh yeah, you're talking about a journey to Mars. You're talking 6 to 8 months.
6 or 8 months. Yeah.
And it's a great question. So you think about, we've been doing a lot of research on this because, you know, we keep thinking about it's only so much, how big can you really build a rocket, right, to have enough energy to carry everything you need to go into space. So a lot of analysis now is going into, well, maybe we can use that lunar orbit, which doesn't have the same gravity well as the Earth, right, as a depot, and then you can have maybe a way to kind of refuel, maybe resupply it at the same time, get a crew a little bit of a break, and then you put them back in there, and then you take off from there. So a lot of studies and mission architects are taking place to say that might be a good depot way to get us out to Mars a lot quicker. Because the rockets, they can only be so big. I mean, just to get out of the Earth gravity well is huge. So that's huge.
What's the goal to go to Mars? Is that 10 years from now or something?
Oh man, I don't know. Don't give our president any more. You know, they may have us trying to do it in 7 years. I don't know if we can make it, but we want to say that in the 2030s time frame. So 2030-ish, I would say. All right, 2030-ish time frame. But you think about again when you're out in those harsh environments. And weight is crucial. Taking care of your health is crucial. Telemedicine would be crucial. There's a lot of things you have to plan for and think of and be ready to respond to when you talk about those harsh conditions. Because at the end of the day, we want you to come home safely. So we spend a lot of time trying to get those systems correct and make sure we're ready to go. All right, great questions, great questions. Yes, sir.
Is there any chance if we're going to launch from the moon that we could use solid propellant as opposed to liquid?
That's been an ongoing battle discussion at NASA for years. So right now, you know, we use the solid rocket boosters, and then we also use liquid oxygen and hydrogen for the external tank. Right now, the SLS picture that I showed you earlier, of course, it's a combination of solids. It has the fifth segment now on the solid rocket boosters. It used to be 4 segments when we had the old shuttle program. And then, but right now it's still a liquid engine that we run. But we have a lot of experience on that liquid engine. So right now, we're looking at that liquid engine with the solid rocket boosters on the side. Okay, great question. Yes, ma'am.
How many astronauts at present are in training to have people ready for these missions?
Y'all asked some great questions tonight. That's good. So I had the pleasure of hosting our 2017 class. They came out to the Marshall Space Flight Center just 2 days ago. So they're still what I would call, from a military perspective, they're in what we call basic training. So they learn about all the basic concepts, things of that nature. But those individuals, and some of those folks are a lot younger than I am. I pick on myself tonight. But some of those individuals will probably have a pretty good chance to do either a lunar type mission and maybe even a journey out to Mars. So you just never know. Right now, we have pretty good interest of folks that want to be astronauts. As Pierre was reading earlier, I was fortunate enough to serve on the 2017 final selection committee for astronauts. And during that particular selection process, we had roughly 18,000 applications. 18,000 applications. We only picked, I think it was 12 was the final number. So that's a daunting task to go from 18,000 down to that final 12. So I'm very proud that, you know, a lot of folks are still interested in the work that we do. And again, I went back to what this gentleman was saying earlier, you know, once they become part of the program, at the end of the day, we want to take them back home safely to their families. So we got a lot of interest in the work we do, but we got some young folks that can really, they're doing a great job with that 2017 class. But also, I got to also pick on, I was also a part of the 09 class as well, selecting those individuals. They are now, some of those astronauts are flying on board the International Space Station. And also, I was fortunate enough to work on the 2013 final class. So we got some great folks out there, smart folks. This is what we need. Great questions. I'll go here, then I'm come back over here.
During this period, did you have any interest to sell
being a member of that class?
I did. They told me I was a little bit too much overweight, but I did. It was a great group of individuals. It's amazing when you see, sometimes we talk about society and all the society problems and things of that nature. But if you look at some of the talented individuals right here at Marion University and across some of these fine universities across the United States, we got some very talented individuals. Individuals that have 2 and 3 and 5 PhDs in totally different fields, engineering and doctorate degrees. I mean, it's amazing the type of talented individuals that we have across this particular country. When I was serving on my first astronaut selection panel, I'll tell you this quick story. So I told my mother, I said, Mom, I'm going to be serving on the astronaut selection panel. She said, really? She said, now what does that really mean, Bobby? I said, well, I'm just going to be helping pick the next group of astronauts. Are you not telling me something? I said, no, I think I'm telling you everything I need to know. Are you planning on going into space? I said, no, ma'am, I'm not planning on going into space. No, I'm a manager, so I don't get to go into space. So, but we got some talented folks out there. But I would love to have gone. It was a young lady, I think, right behind you, too. Then I come back. Oh, maybe it was right here. Okay, it was you. Okay, all right.
Does NASA have a position on the need for a Space Force?
Great question. So that's another initiative that the administration is rolling out. The Marshall Space Flight Center is right there in Huntsville, Alabama. It's located on what we call a Redstone Arsenal. And we have 5 major commands from the Army that sit on that particular base, military base. And NASA is also on there with them as well. So there's been a lot of, and this is just talk now, a lot of talk about the Space Force coming on board and how that would be situated and use a lot of the commands that we have out of the Huntsville proper. Now I'm talking about from a Redstone Arsenal perspective. So I think that's something that could be of a great interest from a NASA perspective. NASA, of course, is based on civilian Space Force. I mean, our job is not to go out and do the job of the military. But if there's a way that we can coexist and work together, I think that'll be a fantastic thing for the agency. So a lot more of the great policy makers in Congress will have to sort those particular details out for us. So a lot is coming, a lot is going on with NASA. Great question. Let me get these 2 ladies over here, then I'll go to the back. Yes, ma'am.
So I know you said that having like a really high level of education, like the multiple PhDs, really gave those 12 candidates like a leg up over others. Like, I'm a junior in high school, and I'd really like to be a significant part of maybe like the journey to Mars. So what's something you think I should really focus on in my career path? Great question.
All right, great question. All right, yeah, give her a round of applause. So one of the things that I look at, of course, it's a team. So I'm on what they call the management team. So there's probably about 3 of us. And then, of course, we're going to have some other astronauts that have flown into space. And then we may have one astronaut that has not flown into space on that final selection board. When you get to the final selection board, there's a lot of, you have probably been interviewed at least, I would say, 3 to 5 times, roughly. You have probably been checked out more times than that. When I say checked out, I won't go into all those details, but you have been checked out on multiple times as well. They look at, and I kind of alluded to this earlier part of my talk, how well you can solve a problem or work within yourself. They also look at how well you can work within a team and the team dynamics. Are you the type of person where you have a very introverted personality, or are you kind of person that's extroverted?
Pretty extroverted.
Okay, all right. So you got to, one thing about you got to know what kind of person you are. So if you're an extroverted person and you're around a person that's an introvert, you may want to give that person a little downtime from time to time. They're not constantly in transmit mode. They're more in receive, and then they want to process what you just told them. So you got to give that person their space. But you think about how those overall team dynamics work. At the same time, one of the things that I look for from an astronaut, potential candidate, you got to be able to deal with hazardous type situations. So you got to think about those extreme sports like mountain climbing, scuba diving maybe. You might want to be a pilot or something of that nature, where a lot of alarms may be going off on you, and you got to calmly process what you've been trained to do and don't overreact, but calmly go through your checklist of things that you know are the right things to do and make the right decisions. Things can happen in space really, really quick. And when things happen really, really quick, you got to have people that have very calm demeanor to work their way through that. At the same time, you're going to have people talking to you right from the ground. You got to be able to articulate, or you got to be able to tell those particular individuals what you are seeing real time as it is happening. And so you can't panic, is what I'm trying to tell you. So you got to be able to stay within yourself and be able to do your job, because that's what you've been trained to do. So those are two things I would point out to you. Hazardous environment. You got to be able to also confine spaces. Even I talked about the size of the Orion spacecraft. Spacecraft that you're going to be on for 6 or 8 months, that's still going to become a small space. So you got to be able to, again, know who you are and be able to work in teams and work in confined spaces and hazardous environments. Those are just a few things I'll pass on to you. All right? All right? So I thought, yes, sir.
Thank you very much for this wonderful presentation. If you need a chaplain on the moon or Mars, let me know, okay?
All right, all right, all right.
So I have 2 questions. Do you have opportunities to visit your center in Alabama? The second question, do you have any sort of collaboration? It's more of a political question than technical. Do you have opportunities to collaborate with the rest of the countries in the world, just like you do with International Space Station?
Right.
Or is just
No, even when we go to, of course, the International Space Station, we have several international partners that we work with from there, everything from our Russian colleagues to our Japanese colleagues to our European colleagues. The same thing will be true when we start doing our missions to the lunar surface and going to the surface of the moon. Also, we're even working the gateway. So we got a U.S. HAB, but we also have what we call a IHAB that is part of the architect as I speak right now. And that IHAB is an international HAB. The international partners will be very engaged in the work that we do, just like our commercial partners will be very engaged. The reason that's important, you think about all the work that we do for NASA and going into space, it's important that we're able to share that overall cost, right? So if we can spread that across other countries and depend on them for certain aspects of the vehicle or certain aspects of the mission, that helps spread our U.S. dollars a little bit further. And the same thing with the commercial companies. We want them to be successful too, but we also realize it's a company, so they got to be able to make a profit when they're doing these particular missions. So the international partners, our commercial companies, as well as universities, will be very involved with what we're doing, continue to do on board the International Space Station each and every day, 24/7, but also they'll be involved with the work we're going to do for Gateway and also returning humans back to the surface of the moon. All right, great question. Yes, sir.
I just kind of wonder what other countries are doing. Like, there's talk about the Chinese wanting to go to the moon. The Russians have never been there because they couldn't do the docking.
Right, right.
They can do it now, but I wonder if they're going to go there. There's just talk about India having astronauts. I'm not sure what range they're talking about. Much talk about.
Yeah, a little bit. So, of course, I do the work that I do for payload operations and 24/7 support for the International Space Station doing science and research. We have these international conferences as well. So, China, of course, is making their presence. They're not. Let me clean. So, China's not at the conference that I went to, but we're aware that China is trying to make a presence on board the moon surface as well. So, and they're trying to advance their system and advance their country to land a human on board the surface of the moon. At the same time, India is starting up they're trying to ramp up a space program as well. There are several countries that are now trying to ramp up a space program. The other big advantage, and I kind of talked about that at the very beginning of my talk, you just never know when that manager or that astronaut, what NASA and what space does, it inspires the next generation to go beyond what they typically can do. And I think that is so important when we can reach out to an elementary school or middle school or high school and get kids interested in excelling or pursuing those STEM type fields of science and technology and engineering or mathematics, computer science. Those are things that are going to richly support this country with new innovations, new technologies that's going to take us further. The better we can educate our country and educate our kids and inspire them to take it to the next level, the better we'll be as a country. It's a great question, because a lot of countries are interested in going to space. And a lot of that rationale is because what it does for the overall population. All right? That's my message. Yes, sir.
I'm curious in terms of NASA in its exploration has both humans and machines or non-humans as well. How do they determine when it's appropriate for humans to do the job and when machines do the job? And when you use humans, how often do you use female humans in the whole thing?
Great question, great question. We have what we call robotic missions. And that's what you was pulling on. We have robotic, James Webb Space Telescope, for example. We have robotic missions and we also have human missions. When you talk about human space flight, we would probably use a robot to maybe go out and do some samples or early type environmental sampling for us, things of that nature. But our overall goal is to put humans on the surface of the moon. One of those charts that I talked about, it said the next man and woman will be from the U.S. on a U.S. rocket going to the surface of the moon. So our goal is to get a female on the surface of the moon as soon as we possibly can. Females are doing a phenomenal job. Matter of fact, my boss, Jody Singer of the Marshall Space Flight Center, started her career at Marshall working on the SRBs, or the solid rocket boosters, worked a little bit on external tanks, and now she is the head person of the Marshall Space Flight Center, my boss, that's leading the charge for this heavy lift rocket, as well as the work that I do every day on her behalf, supporting the International Space Station. So females are making a great advancement when it comes to space and some of the STEM fields. The last class of astronauts of 2017, I'm trying to remember. Eileen, you remember? Was it four or five females? So 4 out of 4 or 5 out of 12 were female out of this last class of astronauts. So great question. So they bring a lot to the table. And like I said, my boss, she's tough as nails, and she's something else. She's wearing me out, but she's doing a great job. Hi, Jody. All right. All right. Yes, sir.
With all of these trips to the moon and space, is it concerned about the amount of debris?
Great question. Yes, of course, NASA, along with some other assets, we're able to track, debris and things of that nature. Just for example, I was talking about the International Space Station. Every now and then we do like a reboost maneuver when we see a piece of debris of a certain size or things of that nature. But we're able to identify those debris pieces at this point right now at a certain size. So that's all factored into what we call as a program. I'm just drawing a blank on it now. But we do track debris in space. And there's a lot of space debris. It's unreal. When you see the map sometime, it's unreal the amount of space debris that's out there. Great question. Great question. Let me take one to far back and then I come back over.
Hi.
Yes.
This has been so interesting. I'd like to go a little bit deeper into your scientific research programs, projects. How are they picked? Do businesses or universities present? How often do you use junior high suggestions or grade school or high school suggestions?
Great question. Great question. All right. So she was talking about how do we select the science that goes on board, goes into space. And I'll talk about it from an International Space Station perspective. We have an organization called CASES, and I'm trying to think what that stands for. Google. All right. She's going to look that up for me real quick. She's my right-hand person, so I should introduce her, Eileen Burke. So she's one of my folks that work in my office. But there's an organization called CASES. They look across commercial and universities for different experiments. There was an experiment that we used to fly called, it was like a little basketball, but it's still flying. No, EarthCam, that's what it was. Excuse me, EarthCam. So EarthCam is a camera that we have on board the International Space Station, and it can take pictures of the Earth. And it's actually controlled, if I'm not mistaken, by elementary schools all across the country. But what I need to, and we'll talk at the end, I'll see, can I give you my card, and I'll follow, because there's some folks in Huntsville that support that particular program. But it talks about how middle schools and elementary schools can actually, there's a segment of the day or of a region or a period of time where they can actually go off and guide that particular camera on board the International Space Station from their school. So I'll talk to you a little bit more about that. Great question. Great question. Now, universities, they're going to come in through like the cases. The commercial companies are going to come in through cases. There's also an organization at the Johnson Space Center that's part of the International Space Station program. It's called International Research in Science. They also collect different experiments. A lot of them are done with grants to the universities, and then from those grants, they get a chance to fly their experiment on board the International Space Station. I'm almost sure we do a similar thing when it comes to some of the science and research that we'll do for the 2024 timeframe when we start talking about science and research on board the Gateway and also for the lunar surface. Okay? All right, great question. Remind me to give you your card because cases, we got to get that information for you. Okay? All right? Yes, ma'am.
Thank you for the answer to my daughter and
okay.
presentation. All right. My question is there a single rate limiting step that's keeping us from Mars? We've sent multiple unmanned missions to Mars. We communicate with those robots and rovers on Mars. Is it life support required to get people to Mars, or is there any single rate limiting step, or are there multiple?
Great question. Awesome question. Well, of course, funding is going to be one of them, but you're absolutely right. I talked a lot about materials, but the other thing I didn't talk a lot about, which is also part of my organization, on board the International Space Station, we provide what we call the life support system, LSS, or the ECLSS system. This is how we do clean, we reuse water on board the International Space Station, and also regen air requirements on board the International Space Station. Those systems have to be more advanced than what they are today. We're doing some what we call exploration projects for the life support system for the program now to try to make it more robust. And when I say that, a system where you don't have to have all the hands-on that we do on board the International Space Station, but a system that will run, let's say, for 3 years with minimum hands-on. You may change a filter here, things of that nature from time to time, but they got to be quick and easy to get to. So some of those life support systems have to be worked out. You also have to work out a lot of telemedicine type advancements as well. So those are also going to be some key things that we need to go work on. The type of, they're being inside a capsule, but you got to make sure that capsule has all the right materials where it can safely go to Mars, but also safely return to Mars. So those are things that a lot of the architects, the engineers and scientists are working on, doing all the different mission architects to make all that work. But life support system is going to be a major, major piece of that. Same time, you got to also have the food, right? How do you have enough food and water? So all those particular aspects kind of go into it. So there's a lot of work that's going to have to take place over the next 5 years just to get us to the lunar surface. Once we kind of get that going, and then hopefully commercial can kind of pick up on the work that we're doing from that particular aspect, and then we'll start focusing even more on how to get humans to Mars and back. Because it's, I shouldn't joke like this, but you can get to Mars probably, but we got to get them back home safely. All right? All right, great question.
Cases.
Cases, all right, cases, here it comes.
Stands for the Center for the Advancement of Science in Space, also known as the ISS National Lab, and they work with companies, commercial companies, government, and schools from high school to college. And we have a number of programs, so there are high school students and even grade school students that have experiments on the International Space Station.
All right, did I help? Okay, all right. Yes, sir.
Would there be any way to use private, like tourism, to help fund these programs? Could you send people into space that can pay a ton of money? The Trumps of the world.
Can he turn that camera off for a second? No, I'm just teasing. So, you think about some of these commercial companies, these are billionaires, they have money, and that helps a lot. So from a NASA perspective, we haven't flown a tourist per se to space. To say we will rule that out or have ruled that out, I would think there has to be some type of legislation or policy or directive put in place for us to go off and do that. A lot of people will argue that, since this is about science and education, should we have tourism or should we be more focused on discovery and exploration type work? So all those debates have to be played out. Those debates were discussed, though, probably 7 to 10 years ago, because I was in Washington, D.C., and that was a big debate about some individuals who want to go to space. Some of the private companies, of course, they can afford to say, hey, we want to send an individual, give them a seat on our spacecraft and send them to do probably, I would say, lower orbit. I don't think they would do a lunar type mission, but I don't know. They have a lot of money. You never know. A lot of money. All right. Great question. Great question. Yes, sir. Let me get this young lady and I'll come back. All right.
So system integration. How is NASA doing integration with these commercial companies, and what are the challenges around that? The hard-end soft integration.
Okay. You're talking about like system, SE&I, systems engineering and integration?
To take, if you have Boeing and you have the
I'll stay on this side.
companies, how do you integrate NASA's structures and systems?
Oh, great question.
That's very complicated, even if it's just in-house.
Right. So, like, for example, I'll talk about it from a SpaceX and a Boeing perspective, since we just did the SpaceX review not too long ago. So you think about a company like...
What was the question?
Oh. How...
The question was, how does NASA integrate their systems with the commercial entities that are supporting them?
So I'll talk about it from a commercial perspective. We just did the SpaceX demonstration launch 1 a few weeks or a few months ago. Very successful launch. At the same time, you think about that particular commercial entity has to go and dock with a government vehicle. So all the different interfaces, the system engineering that goes along with that, to make sure that they can properly do a rendezvous and, the timing and the pace or the speed that they have to come to. So all those things are verified or supported by our engineering community and science and research community. It's based on a set of standards and requirements that we, NASA, levy back onto the commercial company. And then we also have to get some type of test data and look at that test data, analysis data, to see that they can actually meet those particular requirements. So a lot of simulation and modeling also go into that as well. A lot of reviews, a lot of meetings that goes into make that happen. But great question. A lot of systems engineering. It's basically a huge system engineering feat to go make all that work. Yeah. But it's worth it, though. I still think it's worth it. Still think it's worth it. Yes, sir. Then I'll go. I saw one back over here.
My understanding is that on people on a trip to Mars, they're looking at people who intend to stay in Mars for the rest of their life. The problem of getting them off Mars takes a lot of force. What's the status of that right now?
All right, great question. So from a NASA perspective, we do not plan on leaving anybody on Mars. So we take somebody to Mars, we would like to bring them back home to Earth. So there are some companies that have said we would give you a one-way trip to Mars. I don't recommend those, but I mean, you got a nice young lady that's sitting right beside you here, so I'm sure she would want, but she might want to sing you. I don't know. Now that I think about it, I know my wife gives me a hard time sometimes. I don't know. Yeah.
We've been married for all of 3 years, so yeah.
Congratulations. I know she don't want you to have a one-way ticket there. No, yeah. Congratulations. Good deal. Yes, ma'am. Then I'm coming back over here.
I have 2 questions. One, did Homer Hickam work at Marshall?
Yes.
And the second one is, even at 250 miles above the Earth, the astronauts have a great risk of radiation. When we do get on the moon, is the protection going to be the materials or the time exposed, or what's the greater emphasis going to be on?
Great question. So that's why I kept pulling on the materials. So great question. So anytime you go into space, radiation is always a major concern when you go out into space. We got several companies now that are building different types of fabrics or materials that you can wear in space to try to reduce the amount of space that the body is exposed to. At the same time, the vehicle itself, we're trying to make that a little bit more ruggedized so it can try to help also with some radiation concerns. But those are all the kind of things that we started talking about, long-term missions beyond the lunar surface, and even to the lunar surface. Radiation, dust, life support systems, different materials are all going to be major and key things that we're going to have to make sure we solve. Great questions. I'm going to go here, then here. All right. Yes, sir.
16-month round trip, and you stay there a month, I guess. That's 17 months. That's a long time. Is there anything that could speed up the way to get there and back, like a photon? Have they looked at any kind of other propulsion that would? And I don't. Do they coast all? Will they coast all the way, or will they have a burst of energy every once?
It's almost like that slingshot scenario you talked about earlier. But we have engineers that look at these mission profiles and try to figure out different strategies. There's other techniques that could maybe be used from a propulsion perspective. You maybe start thinking about some maybe nuclear type propulsion system. So we got a team of engineers also looking at those as well. Of course, that introduces another set of risks that we have to go make sure that we mitigate, make sure we fully understand. But we are looking at different propulsion systems. And I think somebody was asking earlier about liquid versus solid propulsion as well. So all those things are still on the table. But again, when we start talking about a 5-year program, we got to quickly analyze, see where we are, pick a direction, and then move out with it. So, all right, we got to manage that risk. Yes, sir.
Since the retirement of the space shuttle program, what are the means that the U.S. is using, or the NASA is using, to send cargoes? Cargoes, I know you are partially reliant on the private sector. But how about the astronaut? Are you still relying on the Russian series, or are there any options? Is there any way to revive the shuttle project?
So there's, I shouldn't say no way, but most of the all the shuttle vehicles now are in a U.S. museum across the U.S. So we have retired the shuttle program. Right now, in order to get our astronauts to the International Space Station, they fly on a Soyuz, a Russian space vehicle. Cargo is also sent up by Progress, which is another Russian vehicle. But we have a capability now with those companies that I was talking about, and they have been carrying cargo to and from the International Space Station now for a few years. So several companies already have that capability to do that. At the same time, our next step is now to start flying humans on our U.S. rockets to the International Space Station. So that's hopefully coming later this summer or later this year. All right? Great question. Yes, sir.
So we have a reception outside with some nice light refreshments, and Bobby will be able to talk to you a little bit in conversation. You guys can come up and talk to him afterwards and meet him. Maybe take one more question, and we'll break and go outside.
One more. One more. They want to go outside. You mentioned food, so yeah. Yes, sir.
So how many people at NASA are involved in these programs?
Oh, great question.
And how many more would you like?
You got to give me your name and number. All right, I like your questions. All right. So at the Marshall Space Flight Center, I'll talk about my center at Marshall. So we have roughly about 2,400 civil servants across multiple programs and projects. That includes science and technology projects, International Space Station, SLS, the Space Launch System, the big rocket program that I talked about. So 2,400 civil servants, and then probably about another 5,000 to 6,000 what I call contractor workforce that also support the work that we do there at the Marshall Space Flight Center. And Marshall is probably the third largest center that we have. The Johnson Space Center is a little bit larger, if I remember correctly, and Goddard maybe is just slightly larger. We have been driving those numbers down over the last few years, as you're probably well aware. That's why our commercial partners are so valuable to us. We're trying to figure out ways to be more efficient with the work that we do from a NASA perspective, and just make sure that we're good stewards of the taxpayer dollars. So, but at the same time, we want to make sure that we don't bring in more risk into the system. So we're always trying to figure out new ways to lead risk and to manage risk and to mitigate risk in the system. But at the same time, making sure that we're on the leading edge of discovery with all that we do at NASA. So we got a lot to do in the next few years to make sure that we're successful. Again, thank you guys for having me here at Marion University. I can see right now our future is bright because some of the questions you guys are asking me, I'm going to take this back to my staff and make sure they can answer those same questions as well. So you guys keep up the great work, and it's my pleasure to be here.